Okay, let's get started. So it's great to see so many of you in here. It's fantastic to see so much interest in something like a preview service, like the Azure Container Service that we're going to talk about here. So I'm going to do a very quick introduction as to what we're going to talk about, and then Soria here is going to do plenty of live demos, and we'll try and explain everything that's going on. There's too many people here for us to do these shout-out questions as we go through, but we will try and get some questions in at the end. So my name's Ross Gardler. This is Soria Das.
Hi, everyone.
And we're going to talk about building applications using the Azure Container Service. Now, we're not going to get into the code of the applications. We're going to talk about how you build and deploy applications, how you build the containers, and how you orchestrate those applications. So in terms of agenda, I'm going to assume that there's a few people in the room that have heard about containers. They understand that this is an important new approach to building applications, but haven't really seen them in action. So Soria's first demo is kind of a Docker 101, and we'll talk more detail about what Docker is and what its relationship is to containers. So those of you who have run containers and understand, the first demo is going to be quite obvious to you, but after that we'll start talking in more detail about the Azure Container Service, and specifically about orchestration. Because building and running a single container is pretty easy. We'll show you how easy it is, but building a full application and orchestrating that is in a production environment is much more complex. So we're going to talk about some of the complexities and some of the solutions that are available to you. And specifically, we're going to talk about the Azure Container Service and how that is a solution for orchestrating. And then finally, we're going to talk a little bit about our strategy around the Azure Container Service. It's 100% open source technologies. We'll talk about detail what that actually means and why we've chosen to take that approach. So, straight over to a demo. Soria, give us the first demo.
Yep, so this is a virtual machine running the Docker engine, and I'm going to show you, the power of containers, how easily you can start up and stop a whole lot of containers. So let's do a Docker PS. What Docker PS does is shows us what processes, how many containers are running in this on Docker engine. As you can see, there's nothing right now. So let's try to run something. So let's do Docker run -d. I'm running it in detach mode, opening up a port with -p, 80 on the virtual machine, and mapping to a port 80 on the container. And I'm pointing at an image in the Docker Hub registry published by Tutum, and it's called Hello World. And then you can see it quickly runs and starts up a container. If you go through the steps, you see that it was unable to find the Hello World image locally. So it went to the Docker Hub registry, pulled it down, and quickly started the container. The D3A right here is the ID of the container. Now if we do a Docker PS, we should be able to see the container ID that's running. And if we do a Lynx localhost, Lynx is a text-based web browser. If we do a localhost, we will see this is basically a simple Hello World application, as simple as a PHP web-based application that prints out Hello World and displays the host ID. And that is what we see here. Now let's go back.
So, hang on a minute, let me make sure I understand. You just downloaded and started up a complete web application with a web server and everything in seconds?
Yes, that is correct.
Okay, cool.
And now I'm going to show you how you can do 20 of them. So I'm going to go into my history and search for this command. And take a look at this command. It's pretty straightforward. It's a for loop of 20, and we are doing the same command, Docker run, running it in detach mode, opening the port 80 on the virtual machine, but not opening up in the containers because port 80 is already open, and Docker will open the ports on each of these 20 containers it starts up. And let's see how quickly it gets done. There you go. We already have 3, 4. And we are
so each one of those lines is a new web server starting up.
It's a new web server starting up. And you can see it's doing it quickly. And you also notice that it did not download it from the Docker registry because it already has a copy in the local cache. And we are done.
I can't download a VM in this speed.
Yep. That is why we are excited about Docker.
Excellent. All right, so that was a really quick introduction to why there's a lot of excitement around Docker. It's the speed at which you can do this. Now, we were running that in a Linux machine on Azure from the command line. We even used a text-based browser, partly because I'm a Linux guy and I wrote these demos, and therefore we do it on a Linux machine, but also because this is a technology that's kind of come from the Linux ecosystem and is very advanced in the Linux space. And so you can do a lot more with containers right now in the Linux environment than you can do in the Windows environment. We'll talk about that soon. And there are sessions here about Windows Server containers, and you should go to those. The key thing is that today, every command that we run in the command line can be run on Windows as well. You don't have to run them on a Linux machine. We will show some web user interfaces later on, but we're going to be in the command line for a while. So, who's heard of Docker? Yeah, most people. Not a surprise. Docker is getting a lot of attention right now. Docker are working in the container space, but one of the things we really need to understand is that containers are not new. The underlying technologies that enable containers like the ones that Surya just run have been around for a very long time in the kernel. There's technologies and features called namespaces and C groups and some other things that those kernel hackers know a lot about. And people are running production workloads using those technologies and have been running production workloads using those technologies for many years. What Docker have done is they've made it easy. They've provided with a set of tools and a packaging standard that makes it possible for mere mortals like me to be able to do things like what Surya just did. It makes it easy to do. You don't have to be a kernel-level hacker. You don't have to understand these underlying technologies. Docker have made it really easy for us to work with those. So we are going to talk about Docker containers during this session because it's so easy to talk about Docker containers. We're also going to talk about a whole load of other tools that are available in the Docker ecosystem. So things like the Docker CLI, which is what you just saw being run there. The Docker engine, which is what makes these things run on the machine. Docker Swarm, Docker Compose, Docker Machine. Many of these things we're going to talk about during this session. This is a graph of tagged posts in Stack Overflow. This is from Danny Berkholz. The link to the original source is at the bottom there. The purple line, the one that's just taking off, is the number of Stack Overflow questions and answers that are tagged with the keyword Docker. And you can see there's a lot of interest, and it's spiking around Docker. But it's really interesting to note that down in the bottom right-hand corner here is a whole load of other technologies. Many of them are growing, and many of them are becoming more and more important as we explore this whole container space that Docker has made possible for us all. So containers are not just about Docker, but certainly containers are commonly about Docker in terms of ease of use. So we're going to talk about containers in general during this session. That means we're going to talk about Docker, but it's more than just Docker as well. So we're going to talk about Docker images, we're going to talk about the Docker tooling for building and managing those images, and we're going to talk about orchestration tooling that you need to go out into production and deploy these things. And then most importantly for us as people who work for the Azure team, we're going to talk about the Azure Container Service as well. So who are we? Already mentioned, I'm Ross Gardler. I'm a program manager in the Linux Azure team. My sole focus is Azure Container Service. I'm an open source guy. My history is very much in open source. I joined Microsoft about 3 years ago now, and I continue to be very actively engaged with open source technologies. If you search the web, you'll find all sorts of things, because of course open source is out there on the web. But perhaps the thing I'm most proud of at this point in time at least is I'm currently the president of the Apache Software Foundation. And it's great to be working at Microsoft and be able to be the president of Apache Software Foundation. This is it's a very different world to the one when I first discovered open source in 1998. Surya.
My name is Surya Das, and I'm also a member of the Azure Linux Compute team. I work on container service, and I also work on the Azure CLI. I have a background of Java development for 6 to 7 years, and I worked for Oracle and Huawei Technologies. And I'm excited to be a part of the open source journey at Microsoft.
Cool. So this is a diagram that I often use to try and describe what container services are, or more to the point, what containers are. On the left-hand side, you see the virtual machines. And we're all fairly familiar with these things. You have a server, you have a host OS, and you have a hypervisor. On top of the hypervisor, you run a complete guest operating system, and then you have all your binaries and libraries that your application needs, and then you have your actual application on top of that. And because you're bringing a complete operating system, these are kind of big. You know, a typical operating system or a typical virtual machine is going to be in the gigabytes range. But you just saw us download a container image in seconds. Clearly, it's not gigabytes. It's megabytes. So you can get a lot more density on your machine. You're not running a whole operating system. You're only running what's necessary for that particular application. And you can see this on the right-hand side. This is the way that we kind of create a picture, a similar picture for, in this case, Docker containers running. You have the server, you have the host operating system, then you have the Docker engine. And the Docker engine is what enables us to start and stop and do the things that Surya just did, along with the CLI that communicates with that engine. And then you can share binaries and libraries across individual applications, across containers. So that makes them smaller still. And then you have your application code on top of that. So containers are much, much smaller. You do get less isolation because you don't have a complete OS. You are sharing things at the kernel level in the OS. So you do have isolation. They're more isolated than processes running on the machine, but they're less isolated than virtual machines. A lot faster to start up and stop because you don't have an operating system. You just saw us do 20 containers in a matter of seconds. So for the rest of this session, we're going to be working with a single demo application. So I'm going to just take you through a very high-level view of what the application is, and Surya will show us it in actual use. So we've got one set of containers that are event producers. So these containers write events into an event queue. Okay, it's a very simple application. It's just generating random events. Some of them are correct answers, and some of them are incorrect answers. And it writes those into a queue. In the case of what we're doing here, it's writing it into an Azure storage queue. But it doesn't need to be. It could be another container with, I don't know, RabbitMQ or whatever messaging system you wanted to have in there. It's just convenient for us to use Azure because we don't have to build that second container in this case. We have a different container that pulls information from the queue and does some processing on it. It's really simple. It simply counts the different types of messages that are going in there. And then it writes the results out to a key value store. In this case, we're using an Azure storage table. Again, it doesn't need to be. It could be another container, or it could be any other service anywhere. There's nothing about this that says you have to do it on Azure. You have to use Azure tables. It's just convenience for us to be able to make sure we complete the demo in time to present it here. There's a web UI. There's also a command line that does the same thing that Surya is going to demonstrate. And that enables us to produce events. Okay, so that enables us to fire into the event producer and say, okay, create as an event. And it also, for convenience, pulls information out of the analysis table and tells us what the status of this application is. So it's really simple. What does it look like in practice, Surya?
Let's go. So we're going to start up a web container, a REST container, and an analyzer container, as Ross just said. And we're going to do it with the Docker compose command. What this command does is, it looks for a docker compose.yaml file, and that's where, in the current directory, and that's where we've defined how we are going to create these containers. And I'm doing it in detach mode. So let's take a look. So it's created a web container, a REST container, and an analyzer in a matter of seconds.
So that Docker compose was like running the Docker run command
Exactly.
three times for each of the things?
Yes.
Okay.
And if we do a Docker PS to see what containers are running, we will see only two of them, the web and the REST, and that is because the analyzer is kind of programmed to be such that if there is nothing in the queue, it will shut itself down. So let's now see what is there in the queue. So I'm going to search in my history. So this is the command docker run, and we are telling it that we have a configuration file. That is where all the information about the Azure storage queue is. And then what we are telling is, go ahead the queue, bring us information about the queue, and display it on the command line. takes a while. Let's go through each one of these. So the queue length, as you can see, is 0. We call it approximately because it is a snapshot at this point. It could have changed a couple of moments from now. And the processed events are the events that are being processed from the queue by the analyzer. Now let's start with adding something to the queue. Again, I'm going to my history and then just scroll. So the command at the bottom. So what this does is it's a simple curl post request. It provides the REST endpoint, which is the HTTP 172, and then it says, this is the name of the queue, and this is the message that you need to log.
So this is like the web UI hitting the event producer?
Yes,
okay.
Absolutely. And then, as you can see, we got a message that this has been successful. Let's clear the screen, and then look at the summary again. Let's look at the summary. As you can see, the queue length has gone up to 1. That's because we added a message, and everything else is empty. Now, we don't have an analyzer running because it stops when we don't have anything in the queue. So let's start up an analyzer. And we can do it by doing Docker Compose up. By running Docker Compose up again, we see that it finds out that the web is already up to date and the rest is already up to date, but it starts building the analyzer.
So what's happened here is it's read that configuration file.
Yes.
And it said, okay, so I need these 3 containers. 2 of them are already running, nothing to do. Oh,
No.
This third one's not running. Start it up.
Yep, exactly.
All right.
And then if you look at the summary again, we will see that the length of the queue is 0, and that's because the analyzer has processed the queue and then put it in the infos line, which is the 4th line from the top. And then if we do a Docker PS, we should not see the analyzer because it's shut down after processing what is there in the queue. Now let's start putting a load on the queue. And I have a simple script. And what this is essentially we are simulating through Apache JMeter a load with 100 concurrent users trying to hit the queue 100 times each. And I'll do a Docker PS to show what is running.
So this is doing like the curl command, but it's doing it many times.
Many times,
All
yeah.
right.
So there you go. You can see all the loads. We have 4 loads running. Let's take a look at the summary and see what is there in the queue right now. There you go. The queue length is approximately 300. And then if we run it again, it would have gone up because we do not have an analyzer running right now. So because the queue, the number of messages in the queue is high, let's run a few more analyzers, not just one. And we can do that by running this command. Now this command, it's similar to Docker Compose up, but then all this does is we are telling it to run 10 analyzers instead of 1 at this time. And you will see that it'll start 10 containers very quickly, and they should be done in a,
So this is interesting. That analyzer 1, it said starting analyzer 1. And the others, it said creating. So we already had one that was created because we ran it earlier, and it's just restarting that one. Whereas the others, it's saying, oh, I haven't got these others, so let's create them and start them.
Yep, let's look at the queue again. And there you go. The queue length has gone down from what we had seen. If we go up and see, we had about 471. Right now, we have 120. If we run it again, it's gone up to 185. And that is because as the load is hitting the queue and putting messages into the queue, the analyzer has gone and taken the queue down to 0. And once it goes down to 0, it shuts down all the analyzers. But the load is still running. And if you do a Docker PS, you will not see any analyzers. So if we run another 10 analyzers, this will probably shut down, clear the queue that we have right now.
Okay. So what you're showing here is the ease that we can define a whole application made up of multiple containers and then scale them up and down depending on the environment and the queue length and things like that.
Exactly. There you go. The queue length is 0 and everything is processed in the queue. Thank you.
Excellent. So we're still in the command line, and we're still talking about deploying all of these containers on a single machine. Okay, so why are we still in the command line? Well, because I like developing in the command line. Maybe you don't. Maybe you want to use Visual Studio. Maybe you want to use some other tool. There are sessions here where the Visual Studio team will show how you can do all this from within Visual Studio and the plans for moving forward with that. If you're more of a command line person, you could do everything in the command line the way that we're doing here. And then in terms of the management, the scaling up and scaling down, well, that's less of a dev operation and more of a kind of ops operation. And so we need to think about how would we do that automatically? You don't want a human being sitting there looking at the length of the queue, scaling up and down. Surely we can automate this. And we will build up to that during this session. But all we've been doing so far is running essentially on a developer workstation. And the developer's now completed his work and he's said, yeah, this works. So let's put it into production. And in reality, when you go into production, you're probably going to put it into the cloud or into your on-premise hosting environment. You're not going to be running it on, sorry, his laptop here. So you need to be able to connect and be able to run these things remotely. But also, when you're running in production, you probably want to be scaling geographically. You will probably want to be having high availability. There are many things that you need to consider in production, and this makes it really complicated. Where am I going to run these commands? Where am I going to put each of the containers? Where are the resources that are available to me? What's the health of my cluster at this point? And it gets really difficult to manage these containers as soon as you get over just a handful of them. We're only using 3 here, but even managing this environment would be very, very difficult. So that's where some other technologies come in and where we start talking about the Azure Container Service. What you need is some orchestration technologies. And within the Docker ecosystem, there's a product called Docker Swarm. That's what the whales with the containers on top is. That's the Docker Swarm logo. And Docker Swarm is a Docker native orchestration technology. Apache Mesos, the one on the right there, is another orchestration technology. It's not Docker native, but it's been around for much longer. It's been running production workloads using that container technology that's been in the kernel for a very long time. Anybody here remember the Twitter fail whale? Not that many. Wow, it's a young audience. The Twitter fail whale was what used to happen when there was too much traffic on Twitter and the application couldn't cope with it. And Apache Mesos was part of the technology that solved that problem, allowed the company to scale rapidly to response in demand, immediate response in demand. It's also used in companies like Airbnb, Apple's Siri uses it, etc. So it's been production tested, but it's not Docker native. It's grown up in the big data world and in message queuing and things like that. It's added Docker support, though. So you can run Docker images using Apache Mesos. If you want to be Docker native, you can do that with Docker Swarm. And what these both do is they give you one endpoint for communicating with your whole cluster, all of your machines where you want to orchestrate these things. And they allow you to define how you're going to orchestrate your application. So you can say, this container must always be co-located with this one, or you must spread these geographically across the globe, or whatever rules that you want to put into place. So the Azure Container Service provides that for you. We provide the infrastructure on which you run these technologies, and we provide the software configured on there. So all you have to do is commands like Docker run or Docker compose, or you hit the Mesos endpoint. We will demonstrate Mesos as well. And the orchestrator decides where everything goes. It also looks after health. It also looks at, okay, I'm supposed to have this many containers running. Are they running? And if not, make them run. And so we don't have to worry about that. It just happens for us. So how does it actually work? Can you show us this running on a cluster?
Yes, so what we will do now is essentially do all the application deployment that we did on our dev machine. We will do it on a pre-configured Swarm cluster that's already running on Azure Container Service. I will show you how to start up a cluster on Apache Mesos in a while from now, but let's right now look into what we have in the Swarm cluster. So this is the same dev box that I had. I'm doing a Docker info to show you information about this container, just to demonstrate that there is nothing here other than this container itself, and this virtual machine itself. And then let's try to SSH into the Docker Swarm cluster.
This is the bit where people's heads explode. How many people here know what SSH tunneling is? All right, okay, about 25%. That's good. Can you explain to the people in front of you and behind?
So I'll explain you this command. What it does is it does a secure shell into, so we are doing secure shell, and what we are doing is we are opening a socket 2375 on the remote cluster, and then here we have the local host, which is this local machine, and then we are opening a socket 2375 on this container, this Docker container itself, and then we are creating a tunnel between the two. -n is to tell them that tell the container that do not create a separate terminal, and then we are giving the name of the server, and then we are -p is saying we will SSH through 2200.
So let me try and recap that for the 75% who don't know what an SSH tunnel
Yes.
is. This is very much a Linux thing, and I suspected that a lot of people wouldn't be familiar with this. Ultimately, what this means is when we run a command on this machine, pointing at the socket 2375, it actually runs at the other end of the tunnel. It actually runs on the Swarm cluster. Go ahead.
Yep. So this is another, I'm just setting up an environment variable to say that whatever command I run from now on, it will run on the cluster and not on my dev box. That is all this command does. And then if I do a docker info now, I should see information about the cluster and not the dev box that I have. So there you go. You can see that this cluster that we have has 3 agents. Each agent is identified by a separate ID that it has. You can see swarm agent 8F-0, and then there's one with -1, and then there's one with -2. So let's go ahead and do the same thing that we did in the dev box, like bring up the REST container, the web container, and the analyzer. And we are going to do it with the same command, which is docker compose up -d. As you can see, it's creating a web, a REST, and an analyzer. Now, if we do a docker ps, what we will see is that we again have the REST and the web and not the analyzer for obvious reasons, because we don't have anything in the queue.
So let's just pause there for a moment. It's a little difficult to read because of the scale of the font, but you ran exactly the same command.
Yes.
Because of the SSH tunnel, it actually spoke to the Swarm cluster rather than the local Docker engine.
Yes.
And it said, stand up these 3 containers for me.
Yes.
And you can see here that if you look to can we highlight it? If we highlight this part here.
Yes.
There, you can see that that one was deployed to machine number 1, and the one below the same line, it was deployed to machine number 2. So what's happened here is the cluster has decided where to deploy these particular containers, but we ran exactly the same command.
Yes. So let's try to add something.
We didn't rehearse that bit. I've thrown him off.
Let's add something to the queue now. So we'll run the same command. Again, we are adding something to the same queue. We are repurposing the queue, the same Azure queue that we had. We are adding a message info hello world to it again. And again, we've been successful. And if you want to see the summary, we can see that the length of the queue now is 1 because we just added the message. And there isn't an analyzer running right now, which is why the length of the queue is that.
So because we're using Azure storage queues and so on, even though this is running on Swarm, we're still seeing the same results from the demos we did on the local machine earlier on.
Yep, we could do a docker compose up -d to start up an analyzer. As you can see, it just went in and saw that the web and the REST containers are up to date, so it didn't do anything with that, just started up an analyzer. And if you see the summary now, we will see that the queue length is 0, and then the info was processed here. It was 1 here, and it is 2 here right now. In the interest of time, I will not demonstrate a load test here, but Corey is doing a Docker Swarm demonstration in his presentation in like an hour from now, so you can go watch that if you like.
Excellent. So let's try and wrap up what happened there. Basically, we used the same containers, we used the same commands, but we deployed to a cluster in Azure. Think about that for a moment. No difference in the tooling that you needed to use to make it run on your local machine in a development environment to how you run it in a production environment. That's really powerful if you think about the portability and the flexibility that that gives you. Not only that, we haven't shown you the Docker Compose file that describes how you do that, but it's the same Docker Compose file. It's configuration as code. Once you know it's working in one environment, it should work in the other environment as well, with just a very simple SSH tunnel and one environment variable change. And that environment variable is only needed at the point of deployment. It's not needed in the application at all. So what's the Azure Container Service? Well, it's built on Azure, clues in the name. It's coming to Azure Stack. It's not in Azure Stack yet. Azure Container Service is in preview right now. Azure Stack is in preview right now. We haven't yet come together, but we will. Azure Container Service is going to GA relatively soon. We went into public preview in February. We're not naming the date yet, but we're very happy with the way things are going. And if you have any feedback, if you have tried it, please let us have that feedback. And we'll be going into GA, general availability, relatively soon. We're building on top of course, VMs and VM scale sets. The VM scale sets are important because what we've shown here is scaling individual containers. But what if you haven't got enough compute power in order to scale? What do? Well, we can use VM scale sets, and it'll scale up for you. We're doing Linux today. We have Linux support today. We don't yet have Windows Server support. Again, Windows Server containers are coming in 2016. They're in the technical previews now. We do have some internal tests that make Windows Server containers work. But there's a whole load of things before we can say, yeah, these are production ready. We need to do more testing, et cetera. And we need Windows Server containers to go to GA themselves. But of course, we're Microsoft. We will bring Windows Server containers. But the really key thing is the commands and the tools that you use to manage them, whether they're Linux or Windows, won't change. You can today run all of the tools that we've run so far on Windows. And so there's no change to the way that you will work with the Azure Container Service when we do bring Windows Server containers. In terms of the tooling that you use, we are very much committed to the publicly defined, the community-defined APIs. And so you can use any tooling that you want to use. As long as it's compliant with those publicly defined APIs that are available in the open source technologies that we're using, then you can use those tools to manage your container workloads. In terms of standing up the ecosystem, we use ARM templates. You've probably come across ARM templates as your resource manager templates. It's a way of defining in code what the infrastructure should look like. And we're actually providing a new resource provider. We'll show you that shortly as to how that works. And then we're working with third parties and first parties to provide first-class support for key technologies. We talked about Docker Swarm, we talked about Apache Mesos. We're working with partners that we'll talk about shortly about those, but sneak peek, surprise, surprise, we're working with Docker. We're also working with Mesosphere, one of the companies that do a lot of work around Apache Mesos. We're working specifically with Mesosphere on components of their DCOS technology. And we're working with Mesosphere to open source components of those, and you can see that starting to happen in the container service today. We'll show you the results of that shortly. We're taking a very layered approach in building the Azure Container Service. And the reason we're doing this is because there's a lot of rapid innovation going on in this space right now. And if we were to pick one particular way of doing something, that means we've got to pick the winner. And I don't know that I can pick the winner today. There are many different solutions to storage, for example, and each solution in storage has advantages and disadvantages, and there's not going to be only one winner. There will be multiple people for different types of use cases. And so our goal is to be very layered about how we implement this. And the layers that you see named on there at the moment, they're the layers we've focused on during the preview to make sure it's rock solid and you can actually deploy containers. We'll talk a little bit about the future shortly. So how do we actually deploy the Azure Container Service? Well, you can use the portal. Today, you can use the portal through Azure Quick Start. Surya is going to show that in a moment. We will have Portal Create once we go to general availability. This is just a quick screenshot of the quick starts, but I'll skip over it because Surya is going to demonstrate it.
All right, so I promised I would show how you deploy a cluster on Azure Container Service. So we can go to Azure Quick Start Templates gallery and search for Mesos. And then we'll see a couple of results here. The Swarm cluster that we deployed was using this one, the second one. We will deploy now a Mesos cluster on Azure Container Service. And all you have to do is deploy to Azure. And let me explain you about what the Quick Start gallery is.
You need to log in. I'll fill that gap for you while you log in. So the Quick Starts are templates that are provided for you by the community. You can go to GitHub and you can find the source code for these. And they're designed to give you demonstrations of how you can build different services. And you can find them for all sorts of things on there, for various open source stacks, for various Microsoft stacks and technologies. And we welcome anybody to come to the Quick Start gallery and contribute to those and show us how to deploy particular workloads there. And then once they're in the Quick Start gallery, you get this Deploy to Azure button that Surya just showed you. And the portal looks like it's misbehaving for us right now. If it comes up, well, you can pick up, you've logged in now. If it comes up, what's going to happen?
Yes, it's going to show us a UI.
Not that one.
Not that one. Let's give it a few more seconds.
All right, you try and fix it, and I'll explain what should happen. So what will happen is that this submits that Quick Start template to the Azure portal, and then in the Azure portal, looks like it's doing it right this time.
Yes, there
Take
it is.
over.
So essentially, it takes you to a UI, a blade on the Azure portal, and you can fill out parameters. As you can see, this is the list of parameters that you need to fill out. There's a DNA prefix. You could give it any name. And then you have the agent count. The agent count can be any number between 1 and 100. Maybe you can leave it with 1 or 2. And then you have a couple of standard inputs, which is like agent VM size is set as standard D2. You could change that. You can change the username. The orchestrator type is set to Mesos already. The master count is you can choose between 1, 3, and 5. 1 is like kicking the tires. You don't care if it goes down. 3 is basically a production environment, and you really care about a master going down and another coming up. And then 5 is like you really, really care about nothing going down. And so I have SSH key. I can quickly copy and paste it here. But once you do that, the subscription is set to a default. You could change that. The resource group, you could select an existing one or type in a new one. And then the group location, there are multiple locations that you can choose to deploy. And then you have to agree to the legal terms. And once you click create, it will start deploying, and it takes about 10 to 15 minutes to deploy the cluster. So I will not start it right now. And then this is one way of deploying the cluster. The other way of doing it is through the command line interface, and I'm going to show you that. It's very simple, 4 commands. The first step is, of course, you have to log in using your credentials. And then you have to set the configuration mode to ARN. You can deploy Azure Container Service only using the ARN mode. And the third step is you create a resource group with this name in West US location. And then this is the final command that actually deploys the cluster. It's Azure Group Deployment Create. You give the name of the resource group. You give the name of your cluster that you want to create, and then you provide a link to the template. This is the template in the GitHub gallery that Ross showed, and then you provide a link to the parameter file. Now this parameter file, all it has is, in the JSON format, it has all the inputs that you entered through the Azure portal, and that's all it is. And then it will deploy, once you run this, it will deploy the cluster with Mesos running.
So we can deploy via the portal. When we get to GA, we'll be able to deploy with the create command in the portal as well.
Yes.
You can do the CLI using the ARM templates, which is what you just showed. And then when we go GA, we'll have CLI commands as well?
Yes.
Okay.
So for the Docker Swarm environment, we showed you through the UI, through the command line interface, to see how many agents are running and all the configuration. For Mesos, we have a couple of simple API UIs. So this is the Mesos localhost. I think I should show you first that I should tunnel into the ACS cluster that we've already deployed. So let me clear the screen, and then sorry, wrong window. Yep. So this is similar to the way we SSH into the Docker Swarm cluster. Again, we are opening up port 80 on both machines and creating a tunnel, and then we are just SSHing in.
So you could do that using something like PuTTY as well?
Yes.
Yeah.
So this creates the tunnel, and then we are, I jumped ahead. What we do is we can use localhost on our Windows machine to see the Mesos UI. And all it does is right now you can see that there are a few completed tasks that we tried to run a few hours back. Nothing is running right now. You can see that there are 3 agents running, and then the resources. There's a total of 6 CPUs, some memory and disk. Everything is idle right now because nothing is running.
So that output on the left-hand side is like when you did the Docker info command?
Yes,
this
it is the Docker
Mesos
info
equivalent of that?
Yes, they've just put it in a UI.
And this is available via REST API as well as the web? Okay.
Yes, absolutely. This is the Marathon UI. You can create an application here. You can create the web, REST, and the analyzer here by clicking Create Application and filling out a few input fields. But you would have to do 3 times, which is why we've created a script for you. We will run that script on the command line, and then we'll come back and see what's going on. So again, I'll pull something from my history. So there it is, the command. All we are doing is a curl request, a put request through the tunnel that we've created, localhost to Marathon. And we are saying that take a look into this marathon.json file. This marathon.json file is equivalent to the docker compose.yaml file, wherein we defined as to what containers we are running and how we are running them. And we are setting the content type to application.json.
So you said it was a script, but actually this is a call to a REST endpoint,
yes,
isn't it?
This is actually.
So this is kind of equivalent, if we think about the Docker environment, this is the equivalent to running Docker Compose.
Yes, okay. This is equivalent. Now if we go back to the UI, we can see that the application is up and running. ACS it is called, and there you go. You can see the REST container, the web container, and the analyzer. You will see that the analyzer keeps going down and coming up. And now let's go take a look at so remember we've been showing you the table summary through the CLI, through the command line. This is the web version of it. All we are showing is, let me just type submit in it. So as you can see, the queue length, we are displaying the queue length, which is 0, and then the summary data. This is actually the same queue. We are repurposing it. We used it for the dev environment. We used it in the Docker Swarm, which is why you can see a bunch of the summary data already in there. Okay, so my message has made it in. The current queue length is approximately 1. That's because I added 1 message. And then Ross is going to start up a load here.
Okay.
And then if we refresh this, we should see that.
So I've just run the same commands we did earlier on that created a whole load of load on the system. I've also got a whole load of analyzers working. Okay,
so that's why you can see the number didn't go up too quickly, even though we ran 100 concurrent users having 100 requests. All right, the queue is pretty up right now. But because he started the analyzers using...
I've just killed them for you.
Okay, so let's go to the analyzer, and we can use this UI to scale the application. We can just say that, increase the analyzers to 20 and just say scale application. See, it started deploying 20 analyzer containers. You can see how quickly it is doing it.
So that was the equivalent of the Docker Compose scale command.
Docker scale.
Could we have done that through the REST API?
Yes, absolutely.
Okay.
And that's it.
Yeah. Okay, so we're going to show automated scaling. I keep promising that we will do that, and we will do. There are many ways you can do auto scaling. But let's first look at what we actually deployed there and what the architecture looks like. This is very, very simple architectural diagram of the infrastructure we stand up for you. On the right-hand side is the agent VM scale set. So remember the parameter of number of agents, 1 through to 100. That's what's in there. And that's where the containers actually get deployed to. That's where these containers we've been starting up are actually being run. The more containers, the more agents you have, the more containers that you can execute in that environment. We're built on scale sets. So whilst we don't support autoscale today in the preview, we will in the future support autoscale. So you'll be able to scale up your infrastructure using the VM scale set technologies. Today, we only support one agent pool, but in the future, we will support multiple agent pools. So whilst you're limited to 100 VMs per agent pool, you'll be able to have multiple agent pools and therefore scale up further beyond that as well. On the left-hand side, you have the master availability set. Now, this is not a VM scale set because your masters, you have 1, 3, or 5. Typically, you pick the right number to start with and you stick with it. It's possible to change the number. It's not the easiest of things, though, because the masters have to agree state amongst themselves. They have to agree on who's leader and things like that. And then we install the software. And this is the hard part. I mean, configuring the infrastructure is hard, but it's wiring machines together, it's putting networks in, it's putting load balancers in, etc. But configuring the software is actually quite difficult, particularly if you're talking about something like Mesos, where over the years, lots of different components have been brought together to provide a rock-solid production environment. In the case of Docker Swarm, it's much easier. You've got a smaller number of components to build there, but it still requires tweaking and fine-tuning. And so behind the scenes, we're providing something on the lines of around about 4,000 to 5,000 lines of configuration code to make this optimal for you. But for you write tens of lines of ARM code in order to deploy all of this. And not only that, but we work with Mesosphere and we work with Docker to make sure that what we're deploying for you is optimal for your kinds of workloads. And so, we have expertise in how you define and configure an Azure infrastructure. And Mesosphere and Docker, they have the expertise in Apache Mesos and in Docker. And they bring that expertise to us, and we make sure that everything is optimally configured for you, so you don't have to worry about it. So we need to, well, you've already done this demo, actually, running it in production. So that was what Soraya was showing, running in a Mesos environment. So back to the layered and flexibility approach that we're taking here. We talked earlier about the layers we've been focusing on. Looking into the immediate future, networking is something that we've heard a lot about. We need better networking support, and indeed Docker are implementing a better networking plugins into the Docker ecosystem as a whole, and we're working with that technology to provide support for things that give you much more flexibility in the way you build your applications. Same with storage. Storage is something that we need a good solution to, and we'll be working on storage. And I've got question marks there because we are in preview. And what we work on in the future is dependent on the feedback we get from that preview. So please give us feedback. Please let us hear what's important to you. The reason we're the reason that we're focusing entirely on the open source technologies and the community-defined APIs and why we're working within those communities and partnering within those communities is because we want to make sure that we enable the ecosystem here. We want to make sure that you can run the workloads you need to run. There's a lot of innovation going on in this space. There's a lot of activity in this space, and we don't want to close off any particular avenue if we can avoid doing so. We want to make sure that we enable people to really move quickly on top of Azure Container Service. So we're focusing on providing a production-grade, enterprise scale, and hybrid Azure environment for running container workloads. And we're working at partnering in the ecosystem to ensure that we get the best of the technologies and we bring the best practices as they emerge in this very innovative environment onto the Azure Container Service. So a couple of examples. I've mentioned both of these companies a number of times. Docker is a partner we've been working with for a long time. Docker have their product called the Docker Data Center. And it's an end-to-end platform that enables everything that we've done here. It enables that portability, the agility, the startup stops, etc. And what we're working with Docker on is making sure that the Azure Container Service with the Docker Swarm flavor is a great place to be able to run their tools that are in the Docker Data Center products, things like the Docker Universal Control Plane and the Trusted Registry and things like that we haven't talked about in this session, but are useful when you're working in the Docker ecosystem at scale. Mesosphere is another partner. I've mentioned how we're working with Mesosphere to open source more components of the DCOS product line that they have. And Mesosphere's product with DCOS has some additional advantages over the Docker native environment for certain kinds of workloads. It grew up in containers generally, not just in Docker environment. And so you can run hybrid container workloads. If you want to run Spark or HDFS, that's Hadoop, or Cassandra, or any of these other technologies, it's been proven in those environments as well. And of course, as we've shown here, you can use Docker images. And again, to reiterate, everything we've done here has used the same Docker image, regardless of which environment we were deploying to, whether it was a single VM, whether it was a cluster, whether it was managed by Swarm, whether it was managed by Mesos, etc. It's always the same Docker image.
So Docker and Mesosphere both have stations in the hub. We highly recommend that you go check them out, the cool technologies that they are working on. They have people out there. You should definitely go check it out.
Absolutely, and I hope there's engineers from both companies in the room, and if you have deeper questions, then maybe they'll be around at the end of this, but certainly they'll be in the hub. Thank you for the reminder. So in both of those cases, we're ensuring that there are people in the ecosystem that can support you with your very complex workloads if you have such things. But if you want to work in the open source space and you want to use the open source technologies and so on, then that's what the Azure Container Service is about. We'll give you that open source technology that you can work on today. And if you move on into working with Docker or Mesosphere or anybody else in the ecosystem, then we are making sure that you have migration paths for that work. So I want to show one more demo. This came in very hot, and therefore it's just a video. It was provided to us by a company called Force 12, and I talked about how we want to enable the ecosystem, and this is one example of that. I've been promising that I would show you autoscale. So Corey in his session is going to show autoscale that we've scripted inside of a Docker Swarm thing. I'm sorry, I forget the name of his session. Can you remember?
It's after
That's
this.
embarrassing because he's our skip level. But he's going to demonstrate autoscale in Docker, and I wanted to demonstrate autoscale in Mesos. So Force 12 is a product that's built on top of Mesos. They call it microscaling in a box, and they focus on scaling container workloads. And so they have this web interface, and you can go into their web interface, and you can define the rules by which you're going to scale up and down. So they've used the same application that we're doing here. And they go very quick, but I'll explain what's happening. And so in the rules that they have, let me pause it for a moment. In the rules that they have, that they very quickly went by, you can define if the length of the queue goes over, I think it's 50 is the number they've made, scale up the analyzers. And if it goes below 50, then start to scale them down again. And so they're starting here. You can see that it's an ACS cluster. You probably can't read it, but it's the same as Surya was just showing here. It's an ACS cluster using Mesos. There's no application currently running. They open an SSH port, a tunnel, just as Surya did. And then they're going to use this tool here, which is doing exactly what Surya did with the curl command, but they're showing you a quick flash of what the JSON is that was being passed into those commands. The end result is the same. When we go back to the Marathon interface here, you can see we've started up the same application. There's the analyzer at the top there, and the bottom one is the producer. So those are the two main components we worked with before. There's a couple of other containers here, though. There's the Force 12 container. That's the one that's querying the queue length and communicating back, etc. And then there's the folding one. The folding one is what we call a low priority job. What folding does is a project called Folding at Home. And what they do is they fold proteins. And so they get workloads from a bunch of very clever people working in drug analysis and things like that. They fold proteins, and they try and predict whether the result would help them create therapies for things like cancer, Parkinson's, Alzheimer's, and so on. And so what we're going to do here is say, if we've not got work on our cluster, let's use up that extra CPU time with this folding at home project and maybe cure cancer in the approach. Not that I'm claiming ACS will cure cancer. It's the smart boffins that will do that, but hopefully will help. Oops, I apologize. I clicked the wrong part of the thing, so let me just, there we go. So in a moment, we're going to go back to the web interface, and you can see here the blue is the analyzers running. The lighter blue is the folding at home. And here we're just going to scale up the producers. We're going to create load on the queue. And when we go back, there's a red line that will start to grow. And hopefully you can see that on the screens, but it's growing. It goes over the trigger level in a moment. There you go. And we've scaled up the analyzers. And you can see that we're scaling down the folding at home job. As the queue shrinks, we shrink the analyzers, and we scale up the folding at home job. Okay, and you can imagine, the demo goes on and does various variations around that, changing things. So now we've gone from doing everything manually in a production environment and testing things out, making sure it scales well and it behaves the way we expect, to putting it into production, in a production-grade work environment on top of Azure, and then having a tool built on top of that as well that will give us auto-scaling. Now, this is not the only approach to auto-scaling. There are many approaches that we can use. So, let's just close out. Got 2 calls to action for you. The first one is, if you have a container workload, a container environment that you would like to see come to Azure Container Service, there are our email addresses. Please get in touch with us. Let's work together. Let's make sure this works for you. And the second call to action is,
please try out Azure Container Service if you still have not.
Yeah,
please do that.
We need your feedback. We're in preview. So we need your feedback. It'd be really, really helpful. And the last piece of feedback as well, of course, is the usual feedback for this session. We're always revising these sessions and trying to make sure they hit. Your feedback is really, really helpful on to whether this has been useful or not. Yes. We have a few moments for questions if we have any. Both Surya and I will be around for a few minutes after the session as well. But are there any questions? Okay, can you use one of the mics for me, please? If there are any others, please just line up at one of the mics. First one to a mic gets the first question. Go ahead.
Okay. So the Docker Azure services is one tool that Microsoft is coming out with. Service Fabric is something that I've heard a little bit about. Can you kind of talk about that? And what the difference is and maybe the right?
Yeah, so Service Fabric is thank you. Service Fabric is more of a PaaS than container service. We're kind of, if you think of a spectrum from IaaS through to PaaS, we're kind of slightly more IaaS, infrastructure as a service, than platform as a service. And what that means is Service Fabric gives you an application model that you can build your applications against, and that will give you some added benefit. It'll give you things like stateful applications, for example. If you're trying to do that inside of a Docker container environment on top of Azure Container Service, you have to manage state within your own application. And so what that means ultimately is Service Fabric will give you more flexibility, will give you more power cheaply, but you have to conform to the way they want to build their applications on that. You can run Docker components, or they are building the support for Docker containers, and it can act as just an orchestrator. And in that environment, I would say the big difference is we're Linux first, and they're Windows first. Does that help? Okay. I've seen a few nods. Great, we're getting the answers for that one. We always get asked that one. It's an important one. Any other questions? Yeah, we have one over here.
So, I've always wondered, Azure is a highly virtualized environment, right? So the machines that we run on Azure are obviously running on some sort of a hypervisor. And now you're running Docker on top of those hypervisor machines. Are you, in fact, eliminating some of the advantages that Docker brings to the table by not running it on the actual host OS on top of the bare metal?
There is a very small impact because you have extra layers on there, but it's tiny. Now, that's anecdotal. We are actually running large-scale tests right now to figure out exactly what the impact of that is, but it's minimal. We're not seeing a big impact at all now.
Is there any plans to allow
We currently don't have any plans, no. We currently don't have any plans. But, you know, what happens in the future, I don't know. We're in preview, feedback is important, but today, no, there are no plans to run on bare metal. One more?
For Microsoft stuff like HD Insight, where it's all Hadoop-based, is Microsoft going to dog food the container stuff that y'all are building to make internal processes easier to grow?
So for that specific case, in the case of HD Insight, they're not currently running on, and as I haven't talked to them about migrating to Azure Container Service. We do have quite a number of internal customers that are running on it, yes, but not HD Insight itself. There are other customers that are looking at that internally, yes. Yeah, we like to dog food. All right, this is the last question, but Sawyer and I will be around and we'll follow up further.
Is there any plans, are you guys looking at unikernels at all for .NET or Node or anything like that?
Our team are not. I can't speak authoritatively as if any other team is, but I know our team are not, no. Okay, so we need to start vacating the room. Thank you very much for your attention. If you have any more questions, then please come.
Yep, thank you so much, guys.